So what we're going to look at today is to start looking at the unit circle and the different values you can figure out on the unit circle without your calculator. Now, certain angles, when you draw those angles, they're going to hit the edge of the unit circle, and those will be coordinates that we're going to look at. So the first family we're looking at are all the angles on the axis. So what we're going to do to start with is we're going to label the angles in degrees and radians, and then we're going to label the coordinates, and while we're labeling the coordinates, we're going to realize, hey, using the big ideas of this unit, and in this one we have two of the big ideas. Coordinates on the unit circle are cos theta comma sine theta. And another big idea was that tan of theta was sine theta divided by cos theta. And just by using the unit circle, we can now figure out a bunch of values of sine and cos and tan without our calculator. So this is how it works. First of all, if you're dealing with degrees, this would be 0 degrees. I guess if you went all the way around, it would also be 360 degrees. If you went to the positive y-axis, in standard position, that would be 90 degrees. If you went to the negative x-axis, that would be 180 degrees, and then 270 degrees. Converting these to radians. Well, 0 is really easy to convert to radians because that's also 0. And we know how many radians are in a circle? 2 pi. So all the way around would be 2 pi. Probably the next one that I would figure out is 180 degrees, because that's halfway around. If all the way around is 2 pi, 180 degrees would be pi radians. Then what fraction of pi is 90 degrees? Half of that. So we can write pi divided by 2. And if 90 degrees is pi divided by 2, can you see that 270 is 3 times that, which would give you 3 pi divided by 2. Now the unit circle is a circle with a radius of 1. So all of these coordinates are really easy to label. Because if you went 1 to the right and no units up, would you agree that this point is 1, 0? And if you went 1 unit up on your y-axis, well, the x-coordinate would still be 0 and the y-coordinate would be 1. If you went 1 to the left, your x-coordinate would be -1, your y-coordinate 0, and 1 down would be 0, -1. And this is where the mental math gets started. I can ask you, what's sine of 90 degrees? And you should be able to tell me without using your calculator. I can ask you, what's cos of pi radians? And you should be able to tell me without your calculator, because the answers are in the coordinates, right? Your x-coordinate is cos. Your y-coordinate is sine. So if I say sine of 90 degrees, go to 90 degrees on your unit circle, look at your coordinate. Sine is the y-coordinate. So sine of 90 degrees is equal to 1. If I say, what's cos of pi? Well, cos is your x-coordinate on the unit circle. At pi, your x-coordinate's -1. So you now know that cos of pi is -1. You can check these things on your calculator, right? You can go make sure your calculator's in radians, then do cos of pi, push enter. It will come out -1. And it's really quite simple from just drawing our unit circle. Now using tangent is sine over cos, and sine is your y-coordinate and cos is your x-coordinate. If you would like to figure out what tangent of 0 is equal to, you would have to do the sine, which is 0, divided by cos, which is 1. 0 divided by 1 is 0. Now, when we get to pi over 2, and I'm going to write all of the tan in radians, but I could have written tan of 90 degrees. It would mean the same thing. When I do sine divided by cos here, I'm going to get 1 divided by 0. What happens when you divide by 0? You get an error on your calculator, right? It's problematic. And so for this one, we're going to write that it's not possible, it's undefined. Tan of 90 degrees does not exist. Tan of pi over 2 does not exist. But when I go over to pi, well, here it would be 0 divided by negative 1. Going to be 0 again. And when you get to 3 pi over 2, negative 1 divided by 0, you're going to get dividing by 0 again, so you can write that that is also undefined. Andre, you're going to pick the first volunteer. The first volunteer is going to tell me what sine of 270 degrees is. I pick the first volunteer. Yeah, you pick someone. Hannah. Hannah. Sine of 270 degrees. Okay, what's the big idea? The big idea is the coordinates on the unit circle are cos comma sine. So when I say 270 degrees, you're here. There's your coordinates. So one of those two coordinates is equal to sine of 270 degrees. Which one would it be? The 0 or the negative 1? Perfect. Okay, you're picking the next volunteer. What is cos of 2 pi? Who are you going to pick? Oh, the revenge pick. Cos of 2 pi would be equal to 1. Perfect. Ooh, we can do negative angles. If I said, what is cos of negative 90 degrees? You got to pick another volunteer. Cos of negative 90 degrees is 0. So negative 90 is not listed on here, but now you have to think, where's negative 90? It would go back to the negative y-axis, and cos is the x-coordinate, which would be 0. This is your first family, the axis family. As you see from your paper, we have 3 more families to go. Now, these values you all memorized once in grade 11, and now we do them again in grade 12, but this time we put them on the circle, and it actually makes remembering them, I'm going to say easier, but you're going to have to find some patterns. The next family is the 45-degree family. So the 45-degree family means that the angle in quadrant 1 is 45 degrees because it has a reference angle of 45 degrees. So everything in the 45-degree family has a reference angle of 45 degrees. So if I go to quadrant 2, see if you can think, well, what angle would that be in quadrant 2? The reference angle is 45 degrees. 180 minus 45 degrees would be 135. In quadrant 3, (180 plus 45 degrees, 225. And in quadrant 4, 360 minus 45 degrees, 315 degrees. So we're thinking about our reference angles all the way through to figure out our angles. We have to do the same idea in radians. So 45 degrees is pi over 4. And then if I want to find quadrant 2, if I use the same idea as degrees, I would have to do pi minus my reference angle. How do you do pi minus pi over 4? You have to remember your fraction work. How do you subtract fractions? Right, so it's over 1 here now. I could make it 4 pi over 4 to have a common denominator. And then 4 pi over 4 minus 1 pi over 4 would give me 3 pi over 4. Can you see in quadrant 3 it would be the same thing but with a plus sign? We have 4 pi over 4 plus 1 pi over 4. This would be 5 pi over 4. In quadrant 4, you would do 2 pi minus pi over 4. How do I write 2 pi as something over 4? You want it as something over 4. Right now it's over 1. Multiply both of them by 4. Agreed. Get 8 pi over 4. And so 7 pi over 4 is quadrant 4. You're going to have to do lots of mental math with fractions, especially with 2 pi, right? You have to be able to say, oh, 2 pi is the same as 8 pi over 4. Oh, 2 pi is the same as 12 pi over 6. 2 pi is the same as 100 pi over 50. You have to be able to get fractions that are equal quickly in your head so that you can do this mental math. Now, something interesting with pi over 4. Okay? First of all, would you agree that pi is here? Pi over 4 means that this was divided into 4 equal sections. Does it look like it's been nicely divided into 4 equal sections? And if this is 1 pi over 4, you could also count. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. You could just keep going. But the counting makes it easier. The other thing that you're going to love about radians is that you often have to find a reference angle quickly. For the pi over 4 family, the reference angle is pi over 4. What do pi over 4, 3 pi over 4, 7 pi over 4, 5 pi over 4 all have in common? They're always something pi over 4. And it's really easy to see the reference angle. Okay? I can tell you right now that if I put something big in degrees, what's the reference angle? Come on, come on. No idea, right? You're like, oh, I don't know. Can you, like, you'd have to keep subtracting 360 a lot of times until you got back to something in quadrant 1, and then you'd still have to figure out the reference angle. Not easy, okay? But if I give you a big angle in radians, I'll pick. If I give you a big angle in radians, and if this number, 117 there, I don't think you can reduce that over 4. Your reference angle is pi over 4. Super easy. If the fraction can't be reduced, it's part of the pi over 4 family. It's really easy to tell. Okay? What's also really going to be nice to tell is that you'll be able to do sine of 1,171 pi over 4 quite quickly. Fairly quickly. Okay. So we've got our angles. We've learned some tricks about the angles already. Now we need to find our coordinates. The big idea in the coordinates is that the coordinates are based on sine and cos. X coordinates cos, y coordinates sine. Sine and cos, you know they're based on triangles. So if I wanted to find cos of 45 degrees, I might look at a right-angled triangle. So what we're going to do off to the side is write, what's our special triangle for 45 degrees or pi over 4? Well, we know SOHCAHTOA comes from right-angled triangles, so I draw a right-angled triangle. And I mark one angle as 45 degrees. If that angle is 45 degrees, then the other angle would be 45 degrees, which makes this triangle special. Not only is it a right-angled triangle, it's also isosceles. When you have two angles the same, it's an isosceles triangle. Every time you have two angles the same, you will also have two sides that are the same. And since sine and cos and tan, when you learn trigonometry, the ratio of the opposite of the hypotenuse doesn't matter how big or how small you make the triangle. You can choose any number you want for these sides. I'm going to choose 1. But if you chose 752, this would work as well. You just have a little bit more mental math to do. I chose 1 because a squared plus b squared equals c squared is going to be a little bit easier than if I chose 752. Okay? What is 1 squared plus 1 squared? What's the hypotenuse going to be? I've got lots of mental math. Square root of 2. And we did all of that without our calculator. Okay? So if you wanted to, over here, do 752 and 752 and do a squared plus b squared equals c squared and reduce it, you get 752 root 2. Okay, perfect. Now, with that triangle, you can now say what sine of 45 degrees is. Because it's opposite over hypotenuse. 1 over root 2. And for today, we will rationalize, so I'll multiply top and bottom by root 2. And it's equal to root 2 over 2. Cos of 45 degrees will also be adjacent over hypotenuse 1 over root 2. So I'll just write it as root 2 over 2 right away. And tan of 45 degrees is equal to 1. Just for fun, if you happen to have used 752, then sine of 45 degrees would be 752 over 752 root 2. Can you see that your 752s would simplify? And you would get 1 over root 2, which is root 2 over 2, exactly the same. This will work with any number, although we tend to use 1 just because the math is easier. But it doesn't matter how big or how small. That's the main idea of trigonometry and sine, cos, and tan. That sine of an angle is the same ratio no matter how big or how small the triangle. That's the power of trigonometry. That's what, that's what makes it so amazing. So now that we've drawn that triangle, and we know sine of 45 degrees is root 2 over 2, and cos of 45 degrees is root 2 over 2, and tan of 45 degrees is 1, well, we can label our coordinates. They're cos, comma, sine. And because each of those points has the same reference angle, means that if you draw the triangle back to the x-axis, you make the same triangle every single time. The ratios are going to stay the same. But in quadrant 2, your x-coordinate's negative, because you're in quadrant 2. You'd have to go back and then up. Your y-coordinate's positive. You would have the same distances in quadrant 3, but your x-coordinate would be negative, and your y-coordinate would be negative. And in quadrant 4, your x-coordinate is positive, but your y-coordinate is negative. Tan of pi over 4 is the same as tan of 45 degrees. We found out that's 1. Can you see that if you use the big idea of sine divided by cos, you'd have root 2 over 2 divided by root 2 over 2. That's also equal to 1. Okay? Probably easiest to see it from the triangle, but you could do sine divided by cos. And because you have the same reference angle, tan of 3 pi over 4 will also equal 1, but this time it's negative, because if you did sine divided by cos, 1 is positive, 1 is negative. Or you could just think of the cast rule. The cast rule says in quadrant 2, only sine is positive. Okay? But the cast rule you just memorized, with the unit circle, everything makes sense. Because the unit circle says if my x-coordinate's if my x-coordinate's cos and my y-coordinate's sine, when I do tan is sine over cos, one of them is negative. Yes? Yeah. And then tan, 5 pi over 4. Negative divided by negative, this will be positive. And finally, tan of 7 pi over 4 will be negative 1. Who was our last volunteer? Thurindu? All right, Thurindu, you get to pick someone to tell me what cos of 3 pi over 4 is. Cos of 3 pi over 4. Shouldn't pick someone so quick, make everybody sweat a little bit, and then pick someone. Negative root 2 over 2. Perfect. What is sine of 7 pi over 4? A little bit of sweat time. Sine of 7 pi over 4? Tanner. Minus root 2 over 2. All right. Should I make it a little bit difficult? Yeah, I'll do a negative angle. Tan of negative 3 pi over 4. Tan of negative 3 pi over 4. So negative 3 pi over 4 isn't listed. You've got to figure out where it is. It's going to be 1. So one of the things with negative 3 pi over 4, first of all, do you see that 3 pi over 4 is here? If you went in that same direction, in the negative direction, does it make sense that it would be there? So often when I'm thinking about negative angles, I think about it positively first. Figure out, oh, that would be in like 2 quadrants positive direction. So now I have to go 2 quadrants in the negative direction. And then negative 3 pi over 4 is coterminal with 5 pi over 4. So I know that it's going to be positive 1. All right, next family. 30-degree family. With the 30-degree family, you know this is all connected to reference angles. So I will write 30 degrees in quadrant 1 and give you 30 seconds head start to finish the rest of the degrees. Okay, check how you did. 150 degrees, 210 degrees, and 330 degrees. A minute head start on the radians. That's pi over 6. Right, you could use your reference angles. Right, you have to subtract your reference angle from pi. You need to make a common denominator. 5 pi over 6. And this one would be 7 pi over 6. And then in quadrant 4, you'd have to do 2 pi minus, how do I make 2 pi something over 6? 12 pi over 6 minus 1 pi over 6, 11 pi over 6. Now, did anybody do the counting technique? Where if I broke this up into 6 parts, there would be another one there, another one there, another one here, and then count 1, 2, 3, 4, 5, 6. No, sorry, I counted wrong. 1, 2, 3, 4, 5. This would be 6. This would be 7, 8, 9, 10, 11, 12. Now, why didn't they include 2 pi over 6 in the pi over 6 family? Well, it's a 60 degree. Why isn't it part of the pi over 6 family? Well, because 2 over 6 actually reduces to pi over 3. And 3 pi over 6 reduces as well. And 4 pi over 6, that fraction reduces. See what I'm saying about the fraction could be in lowest terms? But once you get to 1, 5, 7, and 11, it's already in lowest terms. So some patterns to notice. Now for our coordinates. So in this space that you have right here, special triangle for 30 degrees, again, I make a 90-degree angle triangle with a 30-degree. What's the other angle going to be? 60, because it has to add up to 180. And interestingly, this same triangle is the special triangle for our next family. So we get two triangles in one. Now, this special triangle, 30 and 60 degrees, it's not isosceles because the angles are different. It's a right angle triangle, but we needed a right angle triangle for SOHCAHTOA. What do you call a triangle where all the sides are different and all the angles are different? It's called a scalene. Did you forget that? Because really, it's the name that we give triangles that aren't special. Like, I'm sorry, all your sides are different, all your angles are different, you're not special. But we'll try to make you feel a little bit special by saying, we will give the name scalene to all non-special triangles. Yeah. Yeah, not special. And so, I don't know, does it make you feel any better if like, oh, we'll give you a special name for non-special things? You're scalene. It's almost like, it's like if there were swear words in triangle language, that would probably be one of them, because you're not special. So this poor triangle, we don't know anything about because it's not special. And it's feeling bad about itself. It's not very special. Its head is down. It's walking along and runs into another person. Another triangle, not people here. Another triangle. Also, that triangle, head is down. In fact, it's the exact same triangle, and so they both look at each other. Hi, hi, I'm not special. Neither am I. And they're like, oh, well, do you want to hang out? And the other triangle says, okay, since we're both not, it seems to work. So the other not special triangle decides to hang out with the other not special triangle. They're identical, 30 degrees here, 60 degrees there. They hold hands, and all of a sudden, something special happens. With the two triangles together, what do you get? You get an equilateral triangle. Can you see that all the angles would be 60 degrees? And if it's an equilateral triangle, that means all the sides would be the same. Now again, I can choose any number I want then. The easiest number to work with is 2. Because if this is 2, does it make sense that this is 2? And then the bottom whole thing would be 2, but if I split it up, this side would be 1, and this side would be 1. And now you have enough for a squared plus b squared equals c squared. But you know the hypotenuse this time, so you'd have to do like c squared minus a squared to find b squared. 2 squared is 4, minus 1 is 3. This side will be the square root of 3. And now you can SOHCAHTOA it. I don't know if that's a verb. I just made it up. So if we SOHCAHTOA this, we could find out that sine of 30 degrees, opposite over hypotenuse, is 1/2. Cos of 30 degrees, adjacent over hypotenuse, root 3 over 2. And tan of 30 degrees, opposite over adjacent. And again, we will rationalize this to get root 3 over 3. And since we have this triangle and we're going to need it for 60 degrees, wow, that was fancy. For 60 degrees as well, we'll do sine of 60 degrees, opposite over hypotenuse, cos of 60 degrees, adjacent over hypotenuse, and tan of 60 degrees, opposite over adjacent, root 3 over 1, which we'll just write as root 3. And we have all the values for 30 degrees and 60 degrees. Okay, minute head start for the coordinates, go. How did you do? Root 3 over 2, comma 1/2. Over here, negative root 3 over 2, comma 1/2. Negative root 3 over 2, negative 1/2. And positive root 3 over 2, negative 1/2. Tangent, well, those ones are straight from tangent of pi over 6, root 3 over 3, tangent of 5 pi over 6, negative root 3 over 3, tangent of 7 pi over 6, positive root 3 over 3, and tangent of 11 pi over 6, negative root 3 over 3. So we have a pattern starting to happen. I don't know if you've noticed in the last two special families. Now once you know quadrant 1, the rest of the quadrants are the same. Just positives and negatives change, depending on which quadrant it's in. But the positive and negatives should make sense just because, hey, quadrant 2, I know that my x-coordinate's negative. I know that my y-coordinate's positive. You could also use the cast rule. Right? I know that sine is positive. I know that cos is negative. But I think just the x and y coordinates is probably the easiest to think about it. So we could do mental math again. What is sine of 5 pi over 6? Was Tana the last one? Oh, Samson. Pick a volunteer. Sine of 5 pi over 6. See, if you don't listen the first time, you don't have that ability to start sweating and getting nervous. Sine of 5 pi over 6. 1/2. Okay? I should really make them a little bit harder. What about cos of negative 11 pi over 6? Root 3 over 2. Negative 11 pi over 6 would end here in quadrant 1, right? And then it would be the x-coordinate. All right, one last family. 30-degree family. Okay. So, 60-degree family. We've got our degrees, 60 degrees here, our radians, pi over 3. A minute head start for the degrees and the radians. Check your degrees. Did you get 120 degrees, 240 degrees, and 300 degrees? Check your radians. Did you get 2 pi over 3, 4 pi over 3, and 5 pi over 3? And since we've already done the special triangle, there's our coordinates, and from that, x-coordinate now negative. And finally, tangent of pi over 3, root 3. Tangent of 2 pi over 3, negative root 3. Tangent of 4 pi over 3, positive root 3. And tangent of 5 pi over 3, negative root 3. This is your unit circle. All of these values are now mental math values. So if someone says, what is tan of 4 pi over 3? You're going to say, oh, I know that. It's root 3. It's mental math values, but it might be something that you have to draw out first. And then you use what you drew out as your helpful thing. So in order to make sure that we know this, the next thing we're going to do is take all 4 of the families and put it together on one paper. Oh. Okay? And when I give you this paper, I'm going to suggest, like I've done here, if you color code the families, once you do that family in quadrant 1, you should be able to go across to the green and finish all the green ones quickly. Once you finish the yellow ones, go across to the yellow and finish all the yellow ones quickly. And finally the blue ones, do all the blue ones quickly. Okay? It says quiz at the top because yes, this is your next quiz. This is the only quiz that I actually give you the quiz before you have the quiz. Your quiz will look exactly like this, exact same paper. Okay? What's different about this quiz is there's only 2 possible marks that you get on this quiz. 100% or 0%. You have to get everything right. Right down to the negative and positives. Forget 1 negative, you're at 0. Okay? The other thing that's different about this quiz is that if you don't get 100% on your first try, you do get another try. In fact, you get as many tries as you need within a week. You have a week to get 100%. Many people find out the patterns that make it really easy and get 100% on their first try. But many people also forget a negative, miss one thing, or switch 2 numbers around and have to do it again. And some people have to do it again and again and again and again. And it gets really annoying because it takes about 10 to 15 minutes. Sometimes I've even, do you want it timed the first time? You have to do it all right within a certain amount of time? No? Should aim for about 5 to 10 minutes to do the whole thing. That's what you should practice. Okay, so I will give you this quiz now and you can start transferring the info over.